Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about wireless LAN, wireless local area network and switching. These two topics in detailing clear, we are going to discussing in today's session. First, let us see the overview of today's session. First, we are going to discussing about what is wireless LAN, wireless local area network. And next, we will be discussing out what are the different types of wireless LAN. And next, we have to discuss about what is switching. And next, we are going to discussing about what are the switching modes are there in switching concept. And next, we have to discussing about what are the different classifications of the switching techniques are going to be there. We will be discussing in today's session. These are the three switching techniques are there. Those are the circuit switching, message switching, packet switching. All these three we are going to discussing today's session. First, let us see what is wireless LAN. See, first what is wireless LAN here? Wireless LAN is nothing but wireless local area network. It is a wireless computer network that is a high frequency radio waves. It is using the high frequency radio wave instead of the cables. It is talking about the LAN is nothing but what? LAN is nothing but wired only. We are talking wireless. That is the wireless LAN is nothing but instead of the cables, we are going to use the high frequency radio waves for connecting the devices within a limited area. Within a limited area for connecting the devices, we are going to use the wireless LAN. So, within a limited area forming a local area network, we are going to use the wireless LAN. It is users connected by wireless LANs can move around within this limited area. Means within the limited area only using this wireless LAN we can connect. That like as home, school, campus, office building, railway platforms, we are going to these are the some examples of for connecting the wireless LAN. Means limited area, for connecting limited area, that is also wireless. For that purpose, we are going to use the wireless LAN. The most of the wireless LANs are based upon the standard. What is the standard? IEEE 802.11 standard. That is nothing but Wi-Fi. Means mainly these type of wireless LANs we are seeing in the Wi-Fi connections. For connecting the Wi-Fi within the range like campus, school, home, office building only, we are going to use the Wi-Fi, right? That is the wireless LAN. These are the two types of the services. This wireless LAN is providing two types of services. These two services are BSS, basic service sets, and next one is extended service sets. These two sets are the two types of the services of wireless LAN. First, we will see what is BSS and next we will discuss what is CSS. First, what is BSS? BSS is nothing but what? Basic services sets. What is BSS here? Basic service set, it is a set contains stationary. It is a stationary. It is a mobile wireless station. Already we discussed it is a wireless communication and it is a central base station is there. Here it is a central base station is called, that is a access point. Whatever central base station is called, that is called as access point. The use of the access point is optional. Means here coming to this, see this picture here, this is called as a BSS. BSS means what? Total basic service sets, right? In this, it is a total, what it is, these are all the wireless. There is no wired connection. That is all are the wireless. At the same time, one central base station is there. That is called AP. But in this BSS, it is optional. It is optional. We can take or we cannot take. That is the access point. Access point is nothing but the like router, bridge, switch, all these called as the access points for connecting the devices. So, if the access point is not present, it is known as the standalone network. So, this is the standalone network. Here there is no access point. Such a BSS cannot send the data to other BSS. Means here the BSS cannot send the data other BSS using this particular network. This type of architecture is known as the ad hoc architecture. So, this is the ad hoc network architecture. Means here this is a BSS. This is called as a ad hoc network. Why it is called as ad hoc network architecture? Means here there is no access point. See this picture here, access point is there. There is no access point. At the same time, it is the wireless communication, that is okay. But it is a standalone network. That is the standalone network. At the same time, it cannot send the data to the other BSS. This is the BSS. This is another BSS. Take it as an example. But it cannot send the data to the other BSS. Is called as the ad hoc architecture. And next one is one more case is BSS in which an access point is present. Here there is no access point. but here access point is present, then that is called as a infrastructure network. So it is called as a infrastructure network. Here all stations are going to be there. Here also all stations are there. All are wireless only, but one central access point is going to be there. That is called as a infrastructure network. These are the two types. Ad hoc network, there is no access point. Infrastructure network, there is an access point for connecting the devices. This is about the BSS. And next, ESS. What is extended service set? Extended service set is created by joining two or more BSS. Means already we discussed here, this is the BSS, right? Combining the two or more BSS is nothing but what? Extended service set. So here is the BSS. Combining all is nothing but ESS. So these extended networks are created by joining the access points. How we are going to join these access points? See, set through the wired LAN is known as a distribution system. Through the wired LAN, we are going to connecting these access points. It is known as the distribution system. Means we are connecting the different BSS using the access points used through the wired LAN is called as the distribution system. So these are the two types of stations are there in ESS. First one is the mobile station and the second one is the stationary stations. What is mobile station here? These are the normal stations inside the BSS. Whatever there in the inside the BSS, right? These are called as what? Mobile station. Stationary station is nothing but the access points. Whatever access points is there, right? These are called as the stationary stations. Stationary. It is a part of the wired LAN. It is also part of the wired LAN. So this is the stationary stations. And next one is the communication between these two stations. See here, communication between these two stations, how it is going to be there in two different BSS. So the communication between these two BSS usually occur via two APs. Suppose if two BSS wants to get the communicated, then that time the communication is going through the access points. Through the access points only we are going to connect the through BSS. So the mobile station can belong to more than one BSS. Whatever mobile station is there, right, that is going to belong to more than one BSS at the same time. Suppose these all APs are connected to this particular wired LAN only. That is the wired LAN. Means all AP stations are connected to wired LAN. It is the server. This is the server. This is the server. This is BSS. This is BSS. Combination of all is nothing but what? Combination of all BSS is nothing but ESS. So here the mobile station can belong to more than one BSS at the same time. That is the extended service set. Here access point. The communication between BSS and BSS, how it is going to be happen? Through the access point only. That is also through the wired connection. That is the ESS, extended service set. So 802.11 is talking about what? Already we said that is nothing but Wi-Fi, right? What are the different types of 802.11 is going to be there? See here. So 802.11 defines the three types of stations are there. Those are the no transition mobility, BSS transition mobility, ESS transition mobility. What are the station types? These are the three, right? First, what is no transition mobility? It is talking about these types of stations are similar. Either it is a stationary, immovable. Means it is a stationary or there is no movement is there. Or move only inside the BSS. This is the BSS. Means this is the BSS. BSS means access points there are not. That is the wish. Here this is it is called as a BSS. Means it is going to be moved inside the BSS only, or there is no movement. That is a no transition mobility. BSS transition mobility is talking about these types of transition can move from one BSS to another. Means this is one BSS, this is another BSS. The movement in between one BSS to another BSS is called as the BSS transition mobility. ESS transition mobility is talking about these types of stations can move from one ESS to another ESS. Means between BSS to BSS the movement is there, that is called BSS transition mobility. From ESS to ESS, then that is called as a ESS transmission mobility. These are the 802.11 station types. And the next topic is what is switching. So till now we discussed what? That is about the what we discussed till now. So this is about what? It is talking about, see, this is what? This is the wireless LAN. And next we are going to discussing about switching. This is the next concept. What is switching here? So when a user access the internet. Suppose when I am the user, I want to access the internet or another computer network. I want to access another computer network outside the immediate location. The messages are sent through a network. I want to send the message. The messages are sent through the particular network of the transmission media. That is the switching. See, this is a technique for transferring the information. It is a technique for transferring the information from one computer network to the another computer network. From one computer network to another computer network. This is the one network. This is the another network. For transferring the information between these two computer networks, we are going to use the switching concept. That is the technique. So, transferring the information from the one computer network to another computer network is known as the switching. So, switching in a computer network is achieved by using the switches. In this switching technique, what we are going to use? Switches. What are the switches here? Switching is a small hardware device. See here, switching is a small hardware device. So, what is switch? Switch is a hardware device. First thing, here for switching concept, we are going to use the switches, right? So, these switches it is a small hardware devices which is going to be used to join the multiple computers. Why we are going to use the switches? Suppose this is the switch. Why we are using switch? For joining the multiple computers, we are going to use the switch. So, together with one local area network. Those all can be joined using the switch together with one local area network. These network switches operate at the layer 2, that is the data link layer. Layer 2 is nothing but the data link layer. These can be used in, switches can be used in which layer? Data link layer in the OSI reference model. These switches are used to forward the packets based on the MAC address. How it is going to be forward the packets? What are the frames are going to be come here, right? Those frames are going to be transferred based on the MAC address. Based on the MAC address only, these can be sending and receiving the data. The switch is used to transfer the data only to the device that has been addressed. When the address is, suppose I want to send the data to this particular destination, I have to know the address of this destination. Then only I can send the data. Means that is only if you want to transfer the data, the device has been addressed. Then only we can send the data. It verifies the destination address to route the packets appropriately. If I want to send the data exactly to that particular location, first I have to know the address of the particular destination, that is the MAC address. That is called as a switching. So, what are the main advantages of this switching? Switching increases the bandwidth of the network. It reduces the workload on the individual PCs. Mainly it reduces the workload. It sends the information to only that device which has been addressed. Means mainly it is talking on the switching is talking about what? Which destination I have to send the data. To that destination only we are going to send the data. That is the advantage. It increases the overall performance of that particular network by reducing the traffic on the network. By reducing the traffic, it increases the performance also. These are the advantages of the switching. And next one, disadvantages of the switching. A switch is more expensive than the network bridges. Compared to the bridges, the switch is more expensive. The switch cannot determine the network connectivity issues easily. Suppose if we use the switch, it cannot determine the network connectivity issues easily. That is the disadvantage of the switching. And next we will see what are the switching modes are there. Till now we discussed what is switching. Transforming the data in between sender and receiver based on the address we are sending the data. From one network to another network, we are going to use the concept of switching. That is okay. Next, what are the switching modes are there? Layer 2 is nothing but what? Data link layer. Layer 2 switches are used for mainly for what purpose? Transmitting the data on the data link layer only. And it also performs what? It also checks the errors also. Error checking also done in the data link layer when the transmitted and receiving frames. Whenever we are transmitting and receiving the frames, that time we are also focusing on the error checking also. Based on that, we are going to dividing the switching modes. The layer 2 switches forward the packets with the help of the MAC address. How it sends the whatever layer 2 switches are there, how we are going to send the data based on the MAC address only. Medium access control address. What exactly it is saying? It is a unique address. Each device is having this address. Each whatever devices we are using for sending and receiving the data, each and every device is having the unique address. That is the MAC address. This is also called as the physical address of the device. Who will give this particular address? It is the physical address. Who will give this particular address? Whenever the particular device is going to be manufacturing, that time only that particular device we are allocating some particular MAC address, physical address. That is the address of the particular device. That is MAC address. Based on that only we are sending the data to that particular device. So different modes are used for forwarding the packets is known as the switching modes. Means for forwarding the data between the devices, we are going to use the different modes. Those modes are nothing but the switching modes. Those are store and forward access mode, cut through mode and fragment free mode. These are the switching modes. Store and forward, cut through and fragment free. These are the three modes of the switching modes. So each and everything is having the several parts. In that each mode is having the several parts. Those are like preamble, destination MAC address and source MAC address, users data and FCS, frame checksum. These all are the different parts of the particular access mode. Let us see one by one what is store forward, cut through and fragment free. First store forward. So this is the store forward access mode. So store forward is talking about, it is a technique. It is an intermediate node, stores the received frame and then check the errors before forwarding the package to the next node. Suppose here I want to send the data using this access mode, store and forward. First, whatever data is going to be there, whatever received frame is there, first I have to check the errors. Whatever data I received, first I check the errors. If any errors are going to be there, first I will check the errors. After checking the errors, before forwarding only I am checking the errors. Then only that are sent to the next node. That is the store and forward. First it will store. Why it is going to be stored? For checking the errors. After checking the errors, it will send to the destination, next node. That is the store and forward. The layer 2 switch waits until the entire frame has been received. Whatever switch is going to be there, that will wait. This is the switch. This will wait until total frame is going to be received. After receiving the total frame only, after receiving the entire frame, switch stores the frame. First it will store the frame into the switch buffer. Means whatever buffer is going to be there, first it will store. After for receiving the total frame, it will wait for in buffer. So switch memory, we are whatever frame is there, for storing that we are going to use the buffer memory. This process is known as the storing the frame. First we have to store the frame, that is store and forward. First we have to store the frame. Still here we stored. Next, when the frame is stored, then the frame is checked for the errors. After storing all frame, whatever received from the network layer, whatever we have received the data from the network layer, we are storing in the buffer. After storing into the buffer, what we have to check? We have to check for the errors. If any errors are there in that particular frame. So, if any errors are going to be there, the message is going to be discarded. If any errors are there, that is going to be discarded. Otherwise, the message is going to be forwarded to the next node. If there is no errors, what is the case? Then it is forwarded to the next node. This process is known as the forwarding the frame. Means forward the frame. First it will store and then forward the frame. This is the store and forward. How it is going to be happened, store and forward. See, already we said in these we are having the preamble, destination address, MAC address, that is the source address, next ether type and data and FCS. These all are having the store and forward technique, right? So it is talking about total data, total columns. See, these are total, right? It is talking about all. Store and forward is nothing but checking all. Means it will wait till receiving all the frame. After receiving the total frame, again it will store. After why it is going to be stored? For checking the errors. After checking the errors only, it will send the data. So preamble is talking about the starting of the frame, destination address, which device to which device we have to send the data. Source address, from which device we are sending the data. Ether type is talking about the capacity or payload. Capacity or payload means payload field of the data is nothing but the ether type. And data is talking about what? Data is talking about exact data is received from the network layer. And next one is the FCS, frame checksum. Means error correction and detection, we are going to use the FCS. Already we discussed, it is the 6 bytes, it is 6, it is 6, it is 2. This is the variable length is nothing but the 46 to 1500. And next one, it is having the 2 bytes. This total is called as a store and forward technique. So store and forward technique mainly talking about what? First, whatever data is received from the network layer, Total we have to wait till receiving all the data, that is in the form of frames only. After receiving all the frame, all total frame, it will store in a buffer. It will store in the buffer. After storing, it will check the errors. First it will check the errors, if any errors are there. If any errors are there, if it is going to be any errors, it is going to be discarded. If there is no errors, it is going to be sent to the next node. That is the process of store and forward. And next one is the cut-through switching. What is cut-through switching? It is mainly talking about the forward the switches after the destination address has been identified, without waiting for the entire frame to be received. So in previous case, store and forward, it will wait until receiving the total entire frame. But in this condition, cut-through switching, without waiting for the entire frame, whatever frames are going to be coming, then immediately it is sending to the receiver. That is the cut-through switching. Once the frame is going to be received, it checks the first 6 bytes. Only it will check the first, these two only. 6 bytes only it will check. Afterwards, it is sent to the next one. Means the frame is following the preamble, thus which checks the destination address. Means if it is comes to the destination address, once it knows the destination address, it immediately sends to the packets. It cannot wait for the total. It is not waiting for the total framing receiving. That is the cut-through switching. If the switching table determines the outgoing interface port and forward to the frame to the destination. This is the process, how it is going to be. In previous case, store and forward, till here it is going to be there. Till frame checksum, it is going to be there. Coming to here, it is only checks for the first 6 bytes. That is preamble only. Starting of the address, starting of the frame only. And next, if it is knows the destination address, if where we have to go exactly, that knows, it is sent to the receiver. Immediately it is sent to the receiver without waiting for the entire frame. That is the cut-through switching. And next one is the fragment-free switching. What is fragment-free switching here? See, it is an advanced technique compared to the cut-through and at the same time store and forward. So, this fragment switching reads at least 64 bytes of the frame. So, till here it is going to be read. At least 64 bytes it will read. First 64 bytes, that is also. Before forwarding the next node. Before forwarding the frame, what it will do? First it will check the 64 bytes of the frame to provide the error-free transmission. Why it is going to be checked this at least 64 bytes? For error-free transmission. In previous case in cut-through, it will not check any errors. If it is errors also, if there is no errors also, it will send the data in cut-through. That is the in store forward. After receiving all frame, it will check the error, then only it will transfer. And coming to here, it will check for 64 bytes. If till 64 bytes, if any errors are there, it will identify. Then it will send the data. If any collision is going to be there within the 64 bytes of that particular frame, the frames which are collided will not be forwarded further. If it is any collision is there within the 64, it will to be discarded. If there is no collision within these 64 bytes, it is forwarded to the next node. That is the fragment-free switching. So, till here 64 bytes means preamble, destination address, source address, ether type and data. Till here it is going to be checked. Then after it will forward to the next node. This is about the fragment-free switching. Total how many 3 access modes? 3 switching modes are there, right? 3 switching. What are the 3 switching modes? Store forward, store and forward. And next one is cut through, and next one is what? Fragment free. These three are for forwarding the packets. How we are going to forward the packets using the switching access modes. And next one is the classification of the switching techniques. What are the classifications of the switching techniques CSC? These are the switching techniques classification. 3 types are going to be there. First one is the circuit switching, message switching and packet switching. These are the 3 types of the switching techniques. Circuit, message and packet switching. So again this circuit is going to be divided into space division and time division switches. Circuit is going to be divided space wise as well as the time wise. And message is message only. Packet switching is talking about the datagram approach, virtual circuit approach. Again it is going to be divided into 2. Datagram as well as the virtual circuit approach. This is about the packet switching. These all we are going to discuss it now. First one is the circuit switching. What is circuit switching? It is a switching technique. It establishes the dedicated path. In circuit switching mainly it is having the dedicated path for sending the data between sender and receiver. Means suppose if I want to send the data, so it establishes the dedicated path. This is the dedicated path for sending the data between sender and receiver. This is the dedicated path. Through this path only we have to send the data. That is the circuit switching. In this circuit switching technique, once the connection is going to be established, then dedicated path will be remain to exist until the connection is going to be terminated. Means if suppose the connection is established in between sender and receiver, it is going to be there till connection is going to be terminated. This circuit switching is a network operates. It is similar way to the telephone networks. Mainly this type of communication mainly we are going to use in telephone works. A complete end-to-end path must exist before communication takes place. Means a complete, means from sender end to receiver end, the path is going to be exist in between sender and receiver, end-to-end path. In case of circuit switching techniques, when any user wants to send the data, voice, video, request signal, anything is going to be send the data, receiver to the receiver, then the receiver send back the acknowledgement. Suppose sender wants to send the data, receiver also give the acknowledgement to ensure the availability of the dedicated path. Means whether the dedicated path available in between sender and receiver ensures that the availability of the dedicated path. After receiving the acknowledgement of that particular path only, it will transfer the data. That is the condition in the circuit switching. This circuit switching is used in public telephone network. Mainly where we are going to use public telephone network, we are going to use the circuit switching. It is used for voice transmission. Mainly it is going to telephone is for what purpose? Voice transmission only, right? Used for voice transmission. Fixed data can be transferred at a time. Circuit switching technology. Mainly here we are transferring the fixed data. That is the circuit switching technology. So how it is going to be happen? See here, this communication, it is going to be happen in 3 phases. First thing, what? Dedicated path is there. First we have to circuit establishment. Establish, this is the sender, here is the receiver. In between, first we have to establish the circuit. This is the circuit. S1, S2, S4, S6. We have to establish the connection in between the A and B, sender and receiver. Then after only, this is the dedicated path for sending the data. Means using this particular path only, we have to send the data. That is the condition in circuit switching. This is the circuit switching, right? Based on that only, we have to send the data. Then we can transfer the data. If we establish the connection between the sender and receiver, then it is dedicated path is going to be allocated for the sender and receiver. Then only we can transfer the data. Means we are going to send the data, message 1, message 2, message 3. Like this we are going to send the data. After sending all the messages, then circuit is going to be disconnected. That is the process of the circuit switching. What are the main advantages of this circuit switching? See, the communication channel is going to be dedicated. Means particular channel, if it is allocated, then that is going to be dedicated. It has fixed bandwidth because only we are going to use the particular channel only, particular path only we are going to use. So it is having the fixed bandwidth. What are the main disadvantages of this circuit switching? So once the dedicated path is going to be established, the only delay occurs in the speed of the data transmission. Means if we use, so number of paths are there here for sending the data from A to B, but we are going to use only one dedicated path for sending the data. That means what? Here it delay on the speed of the data transmission also. It takes a long time to establish the connection, approximately 10 seconds, during which no data can be transmitted. That is also disadvantage in the circuit switching. It is more expensive. At the same time, it is more expensive than the switching techniques. Compared to all other techniques, it is more expensive as a dedicated path is required for each connection. Suppose if you want to send any data using these particular circuit switching, first we have to establish the dedicated path. Then only we can send the data. That's why it is also more expensive. This is about the circuit switching. And next one is packet switching. What is packet switching? It is talking about the message is going to be sent in one go, but is going to be divided into smaller pieces. Then it can send in individually. Means whatever data we are sending, whatever message we are sending, right? This is the message we are sending. So this particular message is furtherly is going to be divided into different small frames. Means suppose number of routes are there for sending the data using these. Suppose this is the A, this is the B. If I want to send this particular message, 1, 2, 3, 4 is there. If I want to send this particular message, unwantedly we are not wasting time for a particular path in this particular packet switching. We are dividing these into whatever 1, 2, 3, 4. This is 1 we are sending in this route, 2 we are sending in this route, 3 we are sending in this route, 4th packet we are sending in this particular route for speed of the transmission. That is the packet switching. So we can send individually. So the message split into smaller pieces is known as the packets. These packets are given to a unique number. Each is having the unique number to identify the order. Means this is the packet. We are giving some numbers 1, 2, 3, 4 to identify the packet order. That purpose we are going to give some numbers. So order at the receiving end. When which order we are sending, for that order only we have to receive. 1, 2, 3, 4 we send, right? That order only we have to receive. Based on that only we are going to give some order. If this is first frame is 1, but I received 3 is first. But afterwards we have to rearrange these. Reassemble all the packets. After receiving to the receiver, again we have to reassemble all based on the order to correct order. That is the packet switching. So packets will travel across the network taking the shortest path as possible. Which one is the shortest path? Based on that it will send the data. So at the same time every packet contains some information. It is having the header and it is having the source address as well as the destination address and sequence number. Each and every packet. So this is the packet. This is the frame. This is going to be divided into different packets, right? This is going to be divided into different packets. Each and every packet, this is first one, second, third, fourth. Each and every packet is having the source address, destination address and sequence number. Means first sequence, second one, like that. It is giving some sequence also. Each and everything is contained like this: source, destination and sequence number. Based on that, why we are giving this all? Based on that order only we are, again, whenever the receiver is receiving, that time we can identify easily. For that purpose we are giving some sequence number. So packets are going to be reassembled. If the packets are not coming in order, afterwards we have to reassemble all those receiving at the receiver end in the correct order. If any packet is missing or corrupted, the message will be sent. Suppose I sent 1, 2, 3, 4, but I received only 3, 2, 1 only I received, but I did not receive the 4th packet. If the packet is going to be message, then that time the message will be sent to resend that particular packet. If the correct order of the packets is reached, then the acknowledgement message will be sent. If I received all 1, 2, 2, 4 at the receiver end, acknowledgement, yes, I received all the packets, like that, acknowledgement message will be sent to the sender. That is the process of the packet switching. This packet switching again divided into 2. Datagram as well as the virtual circuit. Datagram, virtual circuit switching. Virtual circuit switching. See here, datagram switching is what is datagram switching? It is also known as the datagram. So it considered as an independent entity. Means each and everything we are going to divide into different packets. Each packet is consisting of the information, right? Which information is having the destination, sequence number, sender address, all going to be there. And forward that packet to the correct destination. Based on that, we are going to send to the correct destination. The packets are reassembled at the receiver end in the correct order. After receiving all the packets, see here, 4, 3, 2, 1 is going to be there. Whenever we are splitting all the packets, they are saying here the number of routes are there for sending the data. So which order we are going to send, that order only we have to receive. If it is not received, what it is going to do? It all going to be reassembled at the receiver end in the correct order. Based on what we are going to reassemble all, we are giving some sequence number for each and every packet, right? Based on that, we are going to reassemble all those. That is the datagram packet switching. In datagram packet switching technique, the path is not fixed. Means whatever path we have to take, we can take. Means based on the distance, we can take any path. The path is not fixed in this datagram packet. Intermediate nodes can take during the routing destinations to forward the packets. Intermediate nodes, these are called as the intermediate nodes. These all are nodes based on the distance we are taking the routes for forwarding the packets. This datagram packet switching is also called as the connectionless switching. So why it is called as a connectionless switching? We are not going in a particular path. We can send based on the we can select any path for sending the data. That's why it is a connectionless switching. Datagram switching is called as a connectionless switching. Like that, we are sending the data between the sender and receiver. And next one is the virtual circuit switching. What is virtual circuit switching here? It is called as a connection oriented. Previously, this one, whatever datagram packet, it is what? It is a connectionless. And coming to virtual circuit, it is a connection oriented. There is a connection is going to be there. So how it is going to be connected? Here is the sender and here is the receiver. If the sender wants to send some data, first it has to send the request to the receiver. Yes, I want to send some particular data. Here he is giving some request. Then he will accept the call. He will accept the call. He is giving some acknowledgement. Yes, I am ready to take the data. Then sender will transfer the data. This is the transfer of the data. After receiving the data, again receiver will give some acknowledgement. Yes, I received the frame. I received the packet. Like that, it is giving some acknowledgement. That is nothing but the clear. Like that, it is a connection oriented switching. Connection oriented is nothing but every time we are getting some acknowledgement from the receiver. Yes, receiving the packets like that. That is nothing but the connection oriented switching. In this case of the virtual circuit switching, pre-planned route is going to be established before the messages are going to be sent. Pre-planned route is going to be established in between sender and receiver. That is the virtual circuit switching. So the call request and call accept are going to be there. Already I said call request and call accept between sender and receiver. In this case of the path is going to be fixed for the duration of the logical connection. Here the path is going to be sent. Path is going to be fixed. The main advantages of this packet switching is it is cost effective because the path is going to be fixed. It is a reliable communication because whenever we are sending, we are receiving some acknowledgement. So it is going to be reliable. And next one is efficient. Efficiency means the packet switching is efficient. It does not require any established path. That's why it is efficient. These are the advantages of the packet switching. And coming to disadvantages of these packet switching are the protocols whatever we are using in the packet switching, those are the very complex and require high implementation cost also. And in the network overloaded or corrupted, if the network is overloaded or corrupted, it requires the retransmission of the lost packets. That is also one of the disadvantages of the packet switching. And next one is the message switching. This is the last one, message switching. So in the message switching, there is no establishment of the dedicated path. In this also, there is no dedicated path for sending the data between sender and receiver. There is no establishment of the dedicated path between sender and receiver. The destination address is appended to the message. The destination where we have to go, that it is appended to the message. The message switching is provided in the dynamic routing. Store and forward, it is having the static routing. That is a fixed route is there. But the difference is here, message switching, it is having the dynamic routing. In store and forward, that is the static routing. As the message is routed through the intermediary nodes based on the information available in the message. Based on the information already available in the message, right? Whatever message we are sending, in that message, we are appending the destination address also. Based on that, it is moving. Which device I have to exactly reach. Based on that, it is going. But the routing is dynamic routing. Whatever route it want to take, that if it will take, that is the dynamic routing. And coming to store and forward, it is having the fixed route. Means dedicated path is going to be there. There in the store and forward. It is the dedicated path. Here there is no dedicated path in the message switching. That is the difference. The message switches are programmed in such a way so that they can provide the most efficient route. And each and every node stores the entire message, then it is forward to the next node. Each and everything here also, it is also going to be stored, then it is going to be forwarded. This type of network is known as store and forward network. Already we said store and forward is nothing but first it will store all the message, then it will check the errors, then it will transfer to the next node. That is the example for that is SMS. Whatever we are saying the SMS, right? That is the example of the store and forward network. This message switching treats each message as a independent entity. So take this message, whatever, suppose this message 1 take this path. Message 2 is taking this path for sending the data. Means this is the dynamic routing. That is about the message switching. And what are the advantages in message switching? Data channels are shared among the communicating devices that are improving the efficiency. And next, traffic congestion can be reduced in this message switching. The message priority can be used to manage the network. These are the advantages. And disadvantages of this message switching are message switches must be equipped with the sufficient storage to enable them to store the messages. And next one is the long delay can occur due to the storing and forwarding. Here also storing and forwarding is there, right? That's why there may be delay also. That is the disadvantage of message switching. This is about the advantages and disadvantages of the message switching. And coming to the today's summary, today we discuss what is wireless LAN. Next we discuss what are the different types of wireless LANs are there. And next we discuss the next topic is switching. What is switching? What are the different switching modes are there? And next we discuss what are the different classifications of the switching techniques are there, like circuit switching, message switching, packet switching. And then we discuss what are the advantages and disadvantages of both all the circuit, message and packet switching. These are discussed in today's session. This all comes under the data link layer only. Thank you.